In this video, we're going to review 5 questions that cover target 1C. We're going to start with number 11, move on to 12, number 13, 14, and 15. Back to number 11. What we have to do here is evaluate this expression and determine if the answer is going to be rational or irrational. And before we get into that, let's review what rational and irrational numbers are. Let's say you have a number that starts with 2, and then you have a decimal, and then it goes into 0, 1, 1, 1, 6, 9, 8, 2, and let's just say that that keeps going on forever with no pattern and it doesn't stop. Well, that's going to be irrational. However, if you have an integer like 3, that's going to be rational. If you have a decimal like 3.1, and that number after the decimal stops and it doesn't keep going on forever, that's rational. If you have like 3.25, it goes out a couple digits farther, that's still going to be rational because it stops. You could even have fractions like 1/4, that's going to be rational. You can even have, let's say, 4.333333. Let's say that keeps on going on forever. Well, that's actually okay because you have 3's that are repeating. There's a pattern there. Or like if you had a 5.232323, and that pattern of 2, 3 keeps repeating, that's also rational. So let me mark R and R. Really, the only time that we have an irrational number pretty much is when you have some sort of number with decimals that just keep going on forever with no particular pattern. Okay, moving on. If we have the square root of 6 times the square root of 6, that means we're going to get the square root of 36. And the square root of 36 is just 6. So we know that's going to be a rational number. It's just an integer, which is okay. That means that this is also a rational number. In this expression, we have this times this. That's going to be ending up a rational number. Okay, moving on to number 12. I'm going to bring my problems before with me. And whenever we add together radical terms, all we do, well, we actually kind of treat that like if we had x plus x, right? Our x's stay the same, but we add the numbers in front. So there's an invisible 1 in front of both of those, so we end up writing 2x, okay? We treat this the same way. So if we have 1 square root of 7 plus 1 more square root of 7, we have a total of 2 square root of 7s. Okay, now is this an irrational number or is it going to be rational? Well, 2 is an integer, that's going to be rational, so let's just ignore that. Let's focus on the square root of 7. Now I did the square root of 7 in my calculator and I get 2.6457. It just keeps going forever. Eventually the calculator stops right here, but we could assume that that continues on to infinity, and I don't see any pattern here. So we're going to call 2 times the square root of 7 here an irrational number because we have a decimal that just keeps going on forever, right? Number 13, we want to evaluate this. So I know that I could simplify 12 over 2. So let's rewrite negative 3. 12 over 2 becomes 6 plus, if I rewrite this as a radical term, I take that 2, swing it around there, it's really going to be the square root of 5, right? So negative 3 to the 6th power, that's going to be 729 plus, well then we have to do the square root of 5. I brought up my calculator again and I did the square root of 5, and that gives me 2.23606, and then so on. It keeps going forever and forever. The decimal's never going to stop, and again it stops here, but that's just because the calculator has to stop somewhere. So if we add this number to this number, it's still going to be irrational. Okay, so this answer is going to be irrational. Number 14 is asking, can the sum of 2 irrational numbers be rational? If so, give an explanation. Or, well, an example. So let's say one irrational number is going to be the square root of 3. And I want to add that to the square root of 2, right? Well, technically, my two irrational numbers here, they cannot be added together because I don't have the same number underneath the radical. So I'm stuck there. And both of these are irrational because if you plug it into the calculator, you'll get numbers with decimals that keep going on forever with no pattern. So let's say we keep the square root of 3 then, and we change this 2 to be a square root of 3 so that we could add these together. Well, 1 square root of 3 plus another 1 gives us 2 times the square root of 3. But again, whenever we multiply 2 times this number right here, the square root of 3 in the calculator will give us a number with a decimal that just keeps going on forever. So it's going to still be irrational no matter what we do. So number 4 will be no, and a couple of these examples are given right here. Number 15 is similar to 14, but it's asking if the product of two irrational numbers can be rational. Well, let's say if I take the square root of 2 and I multiply that by the square root of 3, it is similar to the terms that we used before, that's going to give me the square root of 6. But the square root of 6 will give me some sort of decimal. I'll do it in the calculator. Here it is. It's 2.44948. So again, we get this long, crazy looking decimal with no pattern. So that's going to still be irrational. And we have to figure out basically like how can we take two numbers here and multiply them together to give me a number underneath the radical that would eventually, when we take the square root of it, give me just one number, an integer. And those numbers are going to be perfect squares. So for example, if we take the square root of 25, we know that's going to be 5. We take the square root of 36, that's going to be 6. The square root of 49, we got 7, and so on. So what could we multiply together to get 25 or 36 or 49? Well, that's going to be 5 times 5, right? And then we need them underneath radicals, so the square root of 5 times the square root of 5. These are both irrational numbers because if you take the square root of just a 5, you get that crazy looking decimal. However, if we multiply them together, we get the square root of 25, and when we do that, we just get 5. That's going to be a rational number. So in this situation, the product of two irrational numbers can be rational. Here's an example right here. You could do the square root of 2, which is irrational, times the square root of 2. That gives us the square root of 4. And the square root of 4 is equal to 2. And that, again, is a rational number. So to recap, we had question number 11, moved on to 12, we did 13, 14, and 15. All of these we're working with rational or irrational numbers.